electrostructure. So now you have a two electrode basically, two different dipoles. One is the giant microdipoles, one is the macroscopic dipoles coming from the PVDF. Okay, and due to these two effects, the power density is quite high, particularly for this kind of polymer if we compare. And moreover, it is became very sensitive too. For example, you see the very small object like different types of leaves. Okay, some are like very thin and some are little thick. So if we fall from the top, we can see there is a response, right? So there is a voltage out, right? So and then we calculate the how much pressure we have applied and how much voltage we are getting, because this curve is very important, because if it is nonlinear, then your sensor will not work, right? So this is the sensitivity, and you see up to like 30 pascals we can able to measure by our device. Then we want to use as a healthcare monitoring sector of this sensor. Then what we did, we placed our sensor in the neck, and then we speak out like M, O, F, and we measure our vocal cord response. Okay, see each pronunciation, and if you pronounce this, so your vocal cord is vibrating in different way, and that we are basically recording. If we do the first Fourier transformation, so you see how M, O, and F is behaving. We can see the amplitude is different, time means frequency is different, right? For speak out of this alphabet. So in other words, what we want to tell you that by this kind of sensor, we can also able to track your voice signal in near future. We can discriminate who are the person basically. Like other part, there are some biometric information are there, eye, that. Similarly, like in near future, they will say, okay, you speak A, E, I, O, U, and they will put as a code in the other part. And in near future, if you do some bad criminal activities, or if you do something else, or if they want to identify you by some other means and good things also, then they can use that voice signal as well. So like, and not only that, voice signal is basically carrying a lot of information. For example, if you are sick, then your friend can able to say by calling, okay, you are sick, or possibly you have some problem, because they can identify your voice, very easily. So now our idea is if we can, record our voice in different way, then maybe there might be some way to get, to your health condition or health status by recognizing your voice. So that's our approach. We are working on this. Then we also want to test that yes, our sensor is very much sensitive. So what we did, we measure our pulse rate, wrist pulse rate. So before exercise, is a normal pulse rate is 70 to 72, and you see this the signal. From signal you can understand different the waves, basically P1, P2, P3 is clearly basically we can able to track by our sensor. After exercise or after doing some work, our heart get, more start beating, and you can see this basically rate is increasing, right? So in other words, we can say that by our laboratory make device can able to sense our wrist pulse in a very nice fashion. So that's the basically take home message. Then our another idea is how can we make it to electronic skin. So electronic skin, what does it mean? It is like simply skin, like that we want to mimic. So if we look on our skin, it consists of different type of acceptor, receptor that can have a low modulus tubular dermis layer. This is the inside layer, and this is the outer side layer of our skin, which has the high modulus of epidermis layer. So we have two different modulus, like one is the very hard, another is a soft tissue, yonder wala. And these are the different receptors that can help to sense mechanical energy, mechanical stimuli, temperature, some other means. Okay, so these are the different receptors basically, and then it goes through the nerve and it propagates. So we want to mimic that one. So what we did, we adopt the electrospinning techniques. So this is electrospinning fiber, and this has the low modulus, and in the up we use the electrode. So organic gel electrode, conducting gel electrode we use as a high modulus one. We measure the modulus of electrode and in inside segments, and that data is also mentioned in this particular articles, which became a